Hi, it's Rich Tong here, working on the AI Hub. I'm just doing a little quick demonstration to make sure the my whole chain works. So we're going to show you the various pieces of our new user interface that's based on Open-Webui. It's quite a powerful interface. Everything you see here is running locally. So, for instance, you can see some of the things that you can do. Just give you some samples. So you can have multiple users actually logged in. But it's quite powerful, the settings. So for instance, I can connect to any OpenAI compatible interface. I can connect to OpenAI itself. I connect to Grok, which is an accelerator, DeepSeek, OpenRouter, which gets you to the cheapest possible inference, Mistral, and Cerebrus, which is another vendor that does high performance models. What that gives you is a huge number of models. So here's an example of all the models we have available to us. You can see there's basically everything that's available to you. And we make it very easy to do things like web search. So web searching is available from any of a number of different engine providers. You can also download documents, and we do full RAG inside. The interface itself is very powerful. So for instance, you can look at all the local models. This includes Hugging Face, Google's open source models, Gemma, Mistral's open source models, Qwen, which comes from Alibaba, and so forth. And these are all the models that are available offline. So you can see Anthropic, Google, and so forth. You can also see it's got audio built right in. It's really nice that this is all local, so it can be very fast. So Whisper can be used locally to basically process information, and then we can have a text-to-speech engine coming out. This also supports image settings, so we can do image generation. There are two local models, Comfy UI and Automatic, and then I'm using OpenAI right now just to show the system off. So let's take a look at see how fast it performs. So this is using Llama 3.2. By the way, if you want to just see this, you can just type in, here are the models, and it does full search. And you can see this is a 9.8 billion parameter model taking 7 gigabytes of memory. Down here is this very nice 1.9 gigabyte model. So let's just see how fast it performs. So let's just start with, who is Taylor Swift and why is she famous? Now I'm going to pay the penalty of a full load cycle. So it's actually going to load the model, which it just did. And now it's producing output pretty quick. You can see that performance-wise, it's not too bad. It responded at 118 tokens per second. It read at 244 tokens per second. So very, very competitive speeds for running locally. The second thing I want to show you is that, yes, we really have, when you're local, you can really integrate things much better. So for instance, so I can say, who is Bruce Springsteen and why is he famous? And then it's going to run, I say, who's Bruce Springsteen? And it answers right away. So you get a very natural kind of dialogue going here. I just wanted to show you in that you can basically say, hey, who is, how about the Beatles and why are they famous? So you can see you can actually have an interactive dialogue where and it processed it and returned it. So we're really on the way to a very natural interface going back and forth. A second thing I want to show you is that it's not just for voice, but for vision too. So for instance, let's pick on a vision model. Let's pick on, how about Vision 3.B? And you can see we've got a number of different things we can do. But one of the nice things is I can just upload a file locally. I can pick one. How about my friend Duncan? And say, describe. And now we're going to actually do a vision recognition thing locally. Now, this is a little bit bigger model. It's going to take more time to go through, but you can see what the promise here, being able to run locally, means you can do this processing very quickly. And in the next generation, I think we're going to see even more and even better performance on these kinds of applications. What is going on right now? Oh, there you go. So you can see image shows a man with a receding hairline, graying hair, wearing a white shirt, his neutral expression, professional shot. So actually quite accurate. And the performance isn't too bad. Obviously, it's not going to be as good as these other models because it actually had to process it, run clip transformations on the thing, but very, very usable. And of course, if you're running this in the background, it's not bad at all. I just also want to point out that you can use this to generate images too. So I can also say, do an image generation. And here what I can say, Asians riding a horse. So now what's going to happen is I'm reversing it, and it's essentially going to do an image generation task. So 3.2 Vision is going to interpret this, then generate an image using, in this case, OpenAI. So we've got a full round trip. So there we go. So there you go, the pretty wild thing. By the way, you can also do this kind of crazy thing. You can upload a file, and let me just pick on, let's see, how about, oh yeah, my little doggy. So now we're going to upload this file and say, please make the dog sad. And so what we're doing is we're going to add the image thing from the Vision app, and then it's going to produce text, and then that's going to go directly to the output system. So hopefully we're going to see a sad dog in just a second. Now I want to point out that these 11B models and things are really at the cutting edge of what you're doing, but I just want to show you what's really available now. And so there we go. See if it's a sad dog. That definitely looks like a sad dog, don't you think? So this integration of voice, vision, and text are really happening. Let's take a look, though, at some core performance things. So for instance, I just wanted to go through how good are some of these models. I'm just going to give you some examples. So we have a test corpus here. I just copy this. And so this is basically the way we check to see whether these models are good. And it's very basically a simple mathematical analysis. And what we can do is we can actually tee up a bunch of different models. So Granite 3.1 Dense is the IBM model. Why don't we pick on Llama 3.3, which is the latest, highest performance model. This model is very detailed. It's 70 billion parameters, so it's going to take a little bit of time. And then we can also pick on another model. Let's pick on, I don't know, how about Quen, which is, we've really had some good experience with that model, which is a 30 billion parameter model. It's not going to run all three models simultaneously locally. So I'm asking it to do a lot. And what you're going to see is it's setting up here. So this is the IBM model that just shipped. This is Llama 3 3.270B, and this is Quen 2.5. Now, not surprisingly, the 8 billion parameter model is off into the races generating text. And we're using Llama CPP in the back end. And what that's doing is actually managing the memory so you can have multiple, if you will, agents running to do these calculations, calculating profit, calculating loss margins. This particular scenario is given a simple inventory problem. Can you calculate various ratios and make a recommendation for me? So here's some key ratios. We're losing some money. And that's not too bad. So you can see these models can be very fast. This is running at 67 tokens per second. Let's see what's going on here. So in this particular race, we've got a 70 billion parameter model and a 32 billion parameter model running simultaneously on a single MacBook. Just think about that for a second. And it's going to generate more slowly, but I just want to show you what's capable now between these different models. So this is the 70 billion parameter model, one of the best. This is one of the, about half the size of a model, but very highly performant. It's doing the calculations correctly. 290 are correct. Happen to know these numbers pretty well. It's going through the calculation of inventory sold and so forth. You can't hear it, but right now the processor's going a little quick. And it's doing these calculations correctly for inventory turn ratios and so forth. So very, very quickly, you can see how these agent kind of systems can run by having multiple models. You also see why you need some sort of orchestration tool. If you're running this, you need to know that 70B is going to be a lot slower than 32B, or 8B is going to be faster. And that's one of the things we're doing in Graph AI, which is, again, an open source system that lets you do that kind of planning very easily. And then you get a very responsive system when you need it. And then when you really need detailed calculations, it can slow down and run these high performance models very handily. So you can see it's just finishing up here. So this is just an example of the things you can do. I'm not going to take you through them all, but we typically, when we get a new model, we'll run it through and just see what the performance is like. Note to self, Tulu 3.8b, which is the completely open source model from OpenAI, from AI2, is really good. Quen 2.5 32b is amazingly good for code generation. And we're finding that Llama 3.2 is very, very, very fast. And it's, because it's half the speed, you can leave it in memory. Some of the other ones you might want to take a note of are DeepSeek 2.5. It's a 200 billion parameter model, can't run locally, but is very, very good at a lot of the code generation problems. So this is just wrapping up here. And let me see, what else can I tell you? So this is the way that you can try these models locally. You can see how they perform. You can make sure that they're really great. Let's move on from this local use to what is the future. And so I'm going to take you to a presentation we just did. This was our all hands presentation that we ran. In this case, we're using Google as a demonstrator. There are versions that are available on open source, but I just want to show you the power of this tool called NotebookLM. So in this case, we have a transcript. It's already done a summary, and this is basically a very random, blah, blah, blah summary, a lot of chatting, because it was also our summer holiday party. Mr. Carter, I'm good. The CNO, yada, yada. But buried in this hour conversation are some important facts. And one of the things that's nice about LLMs is you can actually use them to summarize and then create other things. So in this particular case, you can ask questions like, what products were mentioned? And what it's going to do is it's going to actually go through this entire corpus and try to run a summarization using Google's latest models, which are quite good. So you can see there's T&E patterns, T&E persuasion, T&E performance, T&E procedures, and these are actually correct. And when you click on these, you can actually see the exact part of the text where they're being talked about. Right? So first of all, recommendations and so forth. So a very nice way to summarize things. But I think the most amazing part is how you can use to get this to do a interactive conversation. So I'm just going to show you that right now. So what it's going to do is going to take this and basically build a conversation between two people that is all about what this is about, that gives you some feeling for this. And I think this is one of the important futures of computing technology. This is really great, but wouldn't it be much better to hear an interactive dialogue?
Welcome to your personalized deep dive. Today we're slipping you a VIP pass right into the heart of T&E. They're an AI company making waves, and you get to be a fly on the wall for their all-hands meeting from December 13th, 2024.
It's not every day you get this kind of raw, unfiltered look at a company on the rise.
Exactly. Our source.
Do you notice how each of the people have a certain personality? It's not just mechanically reading.
Is the meeting transcript itself, and we're going to pull out the juiciest bits. Where T&E is headed, what they're building, and the personalities driving this whole thing. So to kick things off, who exactly is T&E? What's their deal?
At their core, they're all about AI that helps businesses make smarter decisions. And they're
Now you notice there are some mistakes like IST and so forth, but it's actually quite good.
not just tinkering around the edges, they aim to be cash flow positive in the coming year. What's interesting is they just made a major shift from hardware to a software focus.
That's a big pivot, almost like saying we're not just building the engine, we're crafting the entire car now.
Yep.
But there's a bigger picture here, right? Something about an AI office. That sounds ambitious, even for a company diving headfirst into software.
Ambitious is putting it.
Not bad. Pretty amazing. I think, this is one of the important things to realize is that these kinds of guides and prompting are really the future. And by the way, if you're wondering, our friend Satoshi has just actually built an open source version of this. But I just want to show you what some of the great research work is. So for instance, you can look at study guides, which is basically saying, please generate a kind of summary for me. So turning these kinds of these kind of presentations, and this is just random text, into something that our set of patterns and procedures are really, really important. So why don't we take a look at one of these, the internal briefing. So this just goes to show you, it's a quick summary of everything that's going on. So anyway, I just wanted to use this to give you a guide for some of the great things that are happening, the high performance things. This is a very exciting area, and I can't wait to talk to you more later.